kinetic energy. So basically what you need to learn in chapter 14 are the notations of the book. It's different from physics. Physics you use K for kinetic energy, in the book it's T. In physics you use W for work, in the book it's U. And in physics U is for potential energy, but in the book it's V. So, I guess it's too easy, so they try to make it confusing. So a quick review of what we need to know. So what is the work done by a force?
Force dot distance.
Correct. So if I go from A to B, this is the displacement. So RAB would be the displacement. And let's say you have a force F acting on the object from A to B. The work done by F, so I'm going to use the notation of the book. It's U, so this is work. From A to B, as you said, it's going to be F dot the displacement. So it is a dot product here, so not a multiplication. Now, how do you find the value of a dot product?
You times their components by each other and then add them up.
You can do that, so there are plenty of ways of doing it. So you could say that it is fx abx plus fy aby, and there could be a z. In general, there would be a z, so it would be fz abz. What are some other ways?
Times the magnitudes of the two vectors and by the cosine of the angle between them.
Okay, so it can be magnitude of f times the magnitude of the displacement times the cosine of the angle between them. And there are two ways to interpret that formula. You can put the cosine with the r, or you can put the cosine with the f. You see what it means. So if I have r here, I have f here. What is RAB cosine theta?
It's the projection of R onto F.
Right. So if I draw the line of action of F, this would be RAB cos theta. So you could say work is the product now, not the dot product, of the force and the displacement along the force. This is what we get here. Or you could also say that it is the displacement times the component of the force along the displacement. This would be F cosine theta. So you can say it is this, or you can even say it is F along the displacement times the displacement, or the displacement along F times F. So there are three ways to look at it. now I have a force that varies, and maybe I have a displacement that is not in a straight line. If I have something like this. I go from A to B now doing this. And I have a force F that might be like this here, but it could be like this here. Changes again here, making up some variations. So we don't have the straight path from A to B. And we have F that varies. We can still talk about the work of F. But how would you compute it?
You have to do an integral.
You need to have an integral. What did you say?
Integrate along the curve.
Right. So now what you do, you consider a small displacement along the curve. So for instance, I do it here. You took a small ds. And over that small ds, F is not changing. And ds is small enough so that it is a displacement that is like what we have here. So the amount of work done here would be on f ds, and then you just do an integral, a line integral to do it, to find the full work. So you would get the line integral from A to B of f dot ds.
What if the magnitude of f is changing?
If you take a ds that is small enough, then over the ds, f is not changing. And then, since f is under the integral, of course, f can change from A to B, but it's not a problem, because the integral is going to take this into account. So the goal of the integral is to say, we're going to break our path into plenty of ds's like this. For each little arrow here, you do on f dot ds. And you take the value of f along that ds. If you take your ds that is small enough, f is not changing, just for that small ds. So you get for each one of these, you get a value f dot ds. And then what the integral is saying add them up.
So you're saying, would your f be a function of s then? Or function
Yeah, f could be a function of s.
Should it be a function
Yeah.
of time or something?
Right, yeah. So, but you would have to know what f is doing as you're moving.
What if the theta, what if the angle between f and the ds changes over the integral? Would you have to express the theta?
Well, it would be in there, so f can vary. And the cosine theta would appear in there. You would get f times ds times cosine theta. So all of these would be variables of s. So it can be a mess, yeah. But mathematically speaking, this is the general formula. Strictly speaking, this is what would happen, for instance, if you had some object that is free falling from a very high point. Because we know that the weight actually changes because gravity changes. So if you imagine an object like a parachute, so this would be our y-axis, this is the ground, and let's say you have something that is dropped from a plane that's from a high altitude, and you want to know what is the work done by the weight. So you might have the object that does this, because of the wind or whatever. So you could ask, what is the work done by the weight? Well, the weight is always vertical, of course.